Hello guys, welcome to Introduction to Cybersecurity here on Tryhackme, and in this video I'm going to be starting with Introduction to Offensive Security. Now the Introduction to Cybersecurity module here have already been covered in the Tryhackme pre-security room, so I will have the link to the videos pop up on the screen somewhere around here. Now you can go to cover and watch the video I recorded while I was learning the intro to offensive security, intro to defensive security, and carriers in cyber, all because this is where it appears on the pre-security part, which is the first thing we covered in Introduction to Cybersecurity room here on pre-security. Okay, so that's why we'll be skipping that room or module. I'll be skipping this module to start with Introduction to Offensive Security. Basically, this particular part is short, so it's basically Introduction to Offensive Security and Introduction to Defensive Security. This is just a video that show where I'm trying to revise what I've learned. I'm repeating this. Already cleared this particular part because I've covered it before. If you can see, I already had a certificate before that's downloadable, but I'm still going to go ahead now and start. Now, so the Introduction to Offensive Security, we're starting with the web application security, and in this offensive security we're going to understand what offensive security entails and practice breaking into computer systems by exploiting applications and networks. So without further ado, let's start with the first room here, which is the web application security. Now we're going to learn about web applications and explore some of their common security issues. Okay, now task 1, introduction. Now every one of us uses different programs on our computers. Generally speaking, programs run on our computers using our computer's processing power and storage. Moreover, to use a program, we need to install it first. What if we can use any program without installation? Okay, now a web application is like a program that we can use without installation as long as we have a modern standard web browser such as Firefox, Safari, or Chrome. Consequently, instead of installing every program you need, you only need to browse the related page. The following are some examples of web application: webmail such as Tutanota, ProtonMail, Outlook, and Gmail. Online office suites such as Microsoft Office 365, Word, Excel, and PowerPoint, Google Drive, Doc Sheets and Slides, and Zoho Office, Writer Sheets and Show. Now, another example is the online shopping such as Amazon.com, AliExpress, and Etsy. Okay, now thousands more examples provide a myriad of services. Other examples include online banking, money transfer, weather forecast, and social media. So these are all examples of web applications. Okay, online banking. All right. Now the idea of web application is that it is a program running on a remote server. Now, a server refers to a computer system running continuously to serve the clients. In this case, the server will run a specific type of program that can be accessed by web browsers. Now, consider an online shopping application. The web application will read the data. The web application will read the data about the products and their details from a database server. Now, a database is used to store information in an organized way. Examples include information about products, customers, and invoices. A database server A database server is responsible for many functions, including reading, searching, and writing to the database. Now, the online shopping web application might need more than one database to access. For example, products database. This database contains details about the product such as the name, images, specifications, and price. Customers database, it contains all details related to customers such as name, address, email, and phone number. Now, sales database, we expect to see what each customers have purchased or what each customer has purchased and how they paid in this database. Okay, now we can already see the amount of information stored in any online shopping system. Suppose an attacker manages to exploit or hack the web application and steal the customer's database. In that case, this will lead to a significant loss for the company and its customers. Now, the image below shows searching for an item on an online shopping site. In the simplest version, the search will take 4 steps. The first is that the user enters an item name or related keywords in the search field. The web browser sends the search words to the online shopping web application. Now, the web application queries or searches the product database for the submitted keywords. The product database returns the search results matching the provided keywords to the web application. Now, the web application formats the result as a friendly web page and returns them to the user. Now, this is a web application. For instance, here on the computer, you search an item. The item comes back into an online shopping web application and then queries the product database, searches for the results, brings it back, more like search the database for that particular thing you're searching, searches the result and returns it back to the online web application. Now, from the user's perspective, they will only access an elegant online shop where all the technical infrastructure is hidden. From the user's perspective, of course, they will only access an elegant online shop where all the technical infrastructures are hidden. Now, many companies offer bug bounty programs. A bug bounty program allows a company to offer a reward to anyone who discovers a security vulnerability, weakness in the company's system. The main condition is that the found vulnerabilities within the bug bounty scope and rules. Amongst many others, Google, Microsoft, and Facebook have bug bounty programs. Discovering a bug can earn you from a few $100 to tens of thousands of dollars, depending on the severity of the vulnerability, that is, the weakness you discovered. Now, what do you need to access a web application? For you to access a web application, we need a browser. So, browser should be the answer. Submitted, that's correct. Now we'll head over to tax 2. Tax 2, web application security risks. Now, let's say that you want to buy an item from an online shop. There are certain functions that you would expect to be able to do on the web application. Most straightforwardly, the online order might go as follows. Now, you log in on the website, you search for the product, you add the product to your shopping cart, you specify the shipping address, and you provide your payment details. Now, there are a few main categories of common attacks against web application. Consider the following steps and related attacks. Now, 1. You log in at the website. The attacker can try to discover the password by trying many words. Now, the attacker would use a long list of passwords with an automated tool to text them against the login page. Now, second is that search for the product. The attacker can attempt to breach the system by adding specific characters and codes to the search term. Then the attacker's objective is for the target system to return data it should not, or execute a program it should not. Third is provide payment details. Now, the attacker would check if the payment details are sent in clear text or use weak encryption. Encryption refers to making the data unreadable without knowing the secret key or password. Now, we cannot cover everything, but we will present a few formal categories from OWASP Step 10. Don't worry if these techniques sound alien to you. Tryhackme walks you through each vulnerability. Now, from the OWASP Top 10, we have identification and authentication failure. Now, the identification refers to the ability to identify a user uniquely. In contrast, authentication refers to the ability to prove that the user is whom they claim to be. Now, the online shop must confirm the user's identity and authenticate them before they can use the system. However, this step is prone to different types of weaknesses. Example weaknesses include: now, allowing the attacker to use brute force, that is, try many password using automated tools to find valid login credentials. Here we can use GoBuster and so on and so forth. 2. Allowing the user to choose a weak password. A weak password is usually easy to guess. Okay. 3. Now, storing the user's password in plain text instead of being in encryption. If the attacker manages to read the file containing the passwords, we don't want them to be able to learn the stored password. Now you see, this can be username and password and so on. These are all stored in plain text, so if an attacker has access to this, that's going to be a huge vulnerability right there. Now, broken access control is also one of the OWASP's top 10. Now, access control ensures that each user can only access files, documents, images, etc. related to their role or work. For example, you don't want someone in the marketing department to access or read the finance department's documents. Example vulnerability related to the access control include example of the vulnerabilities related to access control include 1. Failing to apply the principle of the least privilege and giving users more access permissions than they need. For example, an online customer should be able to view the prices of the items, but they should not be able to change them. 2. Being able to view or modify someone else's account by using its unique identifier. For example, you don't want one bank client to be able to view the transactions of another client. 3. Being able to browse pages that require authentication or logging in as an unauthenticated user. For example, we cannot let anyone view the webmail before logging in. 3. That's that for the broken access control, one of the OWASP's top 10. One of the OWASP's top 10 again is injection. An injection attack refers to a vulnerability in the web application where the user can insert malicious code as part of their input. One cause of this vulnerability is the lack of proper validation and sanitization of the user's input. And I think lastly here is the cryptographic failures. This category refers to the failures related to cryptography. And cryptography focuses on the processes of encryption and decryption of data. Now, encryption scrambles clear text into ciphertext, which should be gibberish to anyone who does not have the secret key to decrypt it. In other words, encryption ensures that no one can read the data without knowing the secret key. Decryption converts the ciphertext back into the original clear text using the secret key. Examples of the cryptographic failures include 1. Sending sensitive data in clear text, for example, using HTTP instead of HTTPS, which is a hypertext transfer protocol instead of hypertext transfer protocol secure. Now, the HTTP is the protocol used to access the web, while HTTPS is the secure version of HTTP. Others can read everything you send over HTTP, but not HTTPS. 2. Relying on a weak cryptographic algorithm. One old cryptographic algorithm is to shift each letter by 1. For instance, Tryhackme becomes USZ, IBDL, NF. Okay, this cryptographic algorithm is trivial to break. Okay, so it's more like just shifting. This is great. Now, using default or weak keys for cryptographic function is one of the third example of the failures for cryptographic failures. Now, using default or weak keys for cryptographic function, it won't be challenging to break the encryption that used 1, 2, 3, 4 as the secret key. Okay, so that's that. Now, don't worry if these techniques look challenging or sophisticated at first. Tryhackme has dedicated in-depth rooms to help you understand and experiment with the various attacks against web application. Now, you discovered that the login page allows an unlimited number of login attempts without trying to slow down the user or lock the account. What is the category of this security risk? Identification and authentication failure. So that's what it should belong in. Identification and authentication failures. No. What did I get wrong? Authentication. I spelled that wrong. Authentication. Correct. Now, you notice that the username and password are sent in clear text without encryption. What is the category of the security risk? That should be cryptography. Cryptographic failure. Cryptography failures. Let me see if I got that right. Correct. So that's the answer to the questions below. Now let's head on to the last task here, which is task 3. Practical example of web application security. Now let me quickly view this site while I read through this page. Okay, now we have this task will investigate a vulnerable website that uses insecure direct object references, IDOR. IDOR falls under the category of broken access control. Broken access control means that an attacker can access information or perform actions not intended for them. Now consider the case where a web server receives user supplied input to retrieve objects like files, data, and documents, and that they are numbered sequentially. Let's say that the user has permission to access a photo named let's say img like 1003.jpg. We might guess that they are also img_1002.jpg and 1004.jpg as well. However, the web application should not provide us with the image or provide us with that image even if we figured out its name. In general, an IDOR, which is an insecure direct object reference vulnerability, can occur if too much trust has been placed on that input data. In other words, the web application does not validate whether the user has permission to access the requested object. Okay, now just providing the correct URL for a user or a product does not necessarily mean the user should be able to access that URL. For instance, consider the product page http store.tryhackme.thm/product/product ID equals to 52. Now we can expect the URL to provide details about product number 52, right? Now in the database, items would be assigned numbers sequentially. The attacker would try other numbers such as 51 or 53 instead of 52. This might reveal other retired or unreleased products if the web application is vulnerable. Now let's consider a more critical example. The URL https store blah 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 blah, where ID is 16, would return the user with ID equals to 16. Again, we expect the users to have the sequential ID numbers. Now the attacker will try other numbers and possibly access other user accounts. Now the vulnerability might work with sequential files. For instance, if the attacker sees 007.txt, the attacker might try other numbers such as 001.txt, 006.txt, and 008.txt. Similarly, if you were ID number 16 and the ID number 17 was another user, by changing the ID to 17, you could see sensitive data that belongs to another user. Likewise, they can change the ID to 16 and see sensitive data that belongs to you. Of course, we assume here that the system is vulnerable to IDOR. insecure direct object. That's arrogant references. Okay, all right, click on the view site. We've done that, and let's see this in action. You will see a page showing you an inventory management system. If you click on the planned shipments or tab, you will discover that an attacker has managed to mix things up as part of the sabotage plan. Notice how they send the wrong tires to each assembly line. For instance, they assign scooter tires and motorcycle tires to bike assembly. Let's quickly click on the planned shipment. So you see bike assembly, we are seeing scooter tires and sport motorcycle tires here instead of bike tires, of course. Okay, and under the scooter assembly, we are seeing sport road bike tires and sport motorcycle tires. So they already have this sabotaged. Okay, now for instance, they assign scooter tires and motorcycle tires to bike assembly. If left unfixed, all tires will go to the wrong assembly. We will hack the system back and undo the attacker's steps. On your activity, you can see the activity of one of the users. We have reasons to believe that this website has an IDOR vulnerability. Now, to answer the questions below, check the other users to discover which user account was used to make the malicious changes and revert them. After reverting the changes, what is the flag that you have received? Now, let's quickly click on our activity here. As you can see here, an employee ID 11 is the warehouse supervisor, no recent activity. So what we need to do is to try to change the ID to see if we can get the ID of some of the employees here, and we could figure out who made it, who did this. So I'm going to try even number to the like 12, and then try an even number 10, and then start going down like that. So let's see 12, enter, nothing found. It means probably 11 is the last. So let's try 10. So we have an employee ID 10 out on warehouse, no recent activities. Let's try 9. Okay, this is it. Someone hacked through Alia, the database administrator. So the ID number 9 did it. So we're going to revert the actions, right? Meanwhile, let's say this inventory management system manages all the shipments related to tires. A competitor sent a group of malicious actors to sabotage our logistics. The attackers used the account of one of the employees and mixed up the planned shipments. If incorrect shipments are sent, production will be delayed. And here we can see the attacker used Alia, who is the database administrator. So we're going to revert all the action, and that gives us, yes, Alia fixed the inventory management system, and we have our flag. Okay, we paste our flag and we submit, and that brings us to the end of the room. Thank you for learning with me today, guys. This was an interesting room. Thank you for studying with me. I'll see you guys in the next room on the operating system security. Do have a lovely day. Ciao.